Okay, so this is the review for the first test of the last 6 weeks in Precalculus. This test is going to cover the stuff we've done in Chapter 10, and it also goes back in Chapter 1 for circles and conics. So it's circles, parabolas, hyperbolas, and ellipses. It is all multiple choice in this particular case. Here's some example problems. This one here says, which equation does this graph represent? Now, if you look at the graph itself, some people could say, well, it looks like a circle. Others may say it looks like an ellipse. That part is really not the issue. What really matters is look at your answer choices down here. None of these answer choices are in fraction form. In other words, there is no a squared or b squared. So you got to be dealing with the circle right here. And in order to get a circle, all you need are two things. You need the radius and you need the center. And the radius is the letter R, and the center, we call that HK. So if you go and if you look at this figure here, you can begin to see where the center is going to be. The center is going to be right here. Now again, some people could say, well, how do you know the center is not between those dots? How do you know that? Well, look down here at your answer choices. These are all whole numbers. All right, so if I look at that center has the coordinates of -3, 1. Center has the coordinates of -3, 1, which means that if I'm going to write out this equation, I'm going to have x minus -3 squared plus y minus 1 squared is equal to my r squared. Now I'll clean that up in a second. Well, my radius is nothing more than the distance from the center to the edge, and you can do it in a multitude of ways, but if you just simply eyeball this, you can tell that that radius is going to be 2 units. You can look at it and tell, which is going to make that 4. Okay, so we have x plus 3 squared plus y minus 1 squared is equal to 4. And again, all I got to do is look at your answer choices, and it looks like C has to be the correct choice. C has to be the correct choice. And that's just based on identifying the center and the radius. Remember that the whole thing equals r squared, not r. Right now, is this the only way to do it? No, like I said, you could have just saw that the center was -3, 1 and figured out that as long as you had 3's and 1's in here, you're okay. In other words, you could rule out D automatically, because that's 2 and 1. That left A, B, and C, but then you could reason through that your radius has to be squared. If your radius is 2, then it has to be squared, so that would leave C as your answer choice there. All right, our next problem. I told you on page 206, you're going to need to know those pictures. This says identify the diagram that represents the parabola. Remember, what you're looking at is the intersection of the plane, the flat surface there, and the cones. Which one looks like a parabola? Well, I hope all of y'all can tell the only way that works is with C. That's it. It's with C. A is a hyperbola, B is a circle, D is a ellipse. So the only one that will work there is C. And yes, you will have 1 or maybe 2 questions like that. All right, this is one very much like what we did earlier, and that is identifying the equation. Now, if you look at all those choices, A, B, C, and D, they are all in general format. So you don't know exactly which is which. You don't know if that's a circle, parabola, hyperbola, or an ellipse. And unfortunately, it could be all 4 of those. And the reason I know that is that answer choice C has a squared in it, only 1, so it could be a parabola. Right now, that being the case, though, in answering our question, we can rule out answer choice C automatically. It cannot be an ellipse because an ellipse has to have 2 squares. An ellipse has to have 2 squares. The other 2 things with the ellipse is that your coefficients of the squares had to be different, and the signs of the coefficients, actually I should write it this way, the signs of the squared coefficients They're the same. I'll pause the video for a second and orient this board. All right, so we're looking for our squareds. Do they have different coefficients? All right, if we look up here, answer choice A, our squareds are different. The coefficients are different. Answer choice B, our coefficients are the same in the sense that they're both 2's. Right? So that's not going to work for us there. So we've already ruled out a couple of them. And then, well, answer choice D, those coefficients are. Yep. And are our signs the same for both? Yes. You have a negative here and a negative there. So therefore, the answer choice there has to be A. And that comes from just being able to identify the conic based on the general format there. All right? Next problem. Find the standard form of the equation of the specified ellipse. And as I told you in class many times over, read the problem. It tells you it's an ellipse. So therefore, you don't have to think, oh, is this a parabola or a hyperbola or whatever. It says it's an ellipse. Which means then that all your formulas must include a plus in between your fractions. And then you have an ace, and you also have denominators in your fractions. So you know, and they all should equal 1. So you know you have ellipses here. My suggestion to you was to make a quick sketch of what you're given. You're told that you have foci at negative 3, 5. So if I go over 3 and up 5, one of my foci is at negative 3, 5. And the other one is at negative 7, 5. Now that I've done this, and I can't move that either. All right, this is going to be distorted a little bit. All right, those two are foci right there, at negative 3, 5 and negative 7, 5. And it says you have a major axis of length 8. Now that's going to play into what we're going to do here. First thing though, if these are the foci right here, these are, then the center has to be directly between those two. Now I could sit there and try to figure it out, but I'm just going to use the midpoint right quick. I know that my center is going to have to be negative 7 plus negative 3 over 2, comma, 5 plus 5 over 2. Negative 3 plus negative 7 is negative 10 over 2 is negative 5. 5 plus 5 is 10 over 2. Puts me at negative 5, 5. So I know my center is at negative 5, 5. You know, could I just eyeball that? Probably so. But I wanted to put that midpoint formula up there for people who are watching this. Okay, so unfortunately that does not, well, it might rule out some stuff. Right, so I know I have a horizontal axis, major axis. I know I'm at negative 5, 5. So I know that I should have x plus 5 squared over something plus y minus 5 squared over something. It should all equal 1, and it does. So I want to know, where do I have plus 5 and minus 5? So I have x plus 5. The point is that I can rule out A, I can rule that one out, and I can rule out C. So now I'm just down to B and D. And I could honestly just take a guess at it if I wanted to. If my horizontal axis, my axis is horizontal, and I know my foci are a couple of points away, then I could probably reason through then that D is going to be my correct answer, because I should have a bigger number for A than B in that direction, horizontally like that. I should have that. But that being, you know, it says I have a major axis of length 8. This major axis tells us what A is. If the major axis has a length of of 8, then A has to be 4. It's half of that. And since I'm dealing with squares, 4 squared, which is 16, has to be one of my denominators. And again, if 4 squared is under the x part, I have a horizontal major axis. All of that is leading to the fact that D has to be my correct answer instead of B. If B were correct, then everything would have been rotated 90 degrees. So D, as in dog, has to be my correct answer. Now, could we have finished this out and written the whole equation with a major axis of length? We could have, but we can reason through that D has to be the answer choice. All right, this might look like it's hard, but it's not. It's find the eccentricity of the ellipse. If you will recall, the eccentricity has a formula. It is C divided by A. All we got to do is identify A and C from the equation. Well, remember, A is the square root of the bigger of the two denominators. So in this case, A has to be the square root of 25, which is 5. C, if you will remember, is related to A and B in this manner. C is the square root of A squared minus B squared. Actually, I'm going to write it like this. It's A squared, which is 25, minus B squared, which is 16. So if I take 25 minus 16, and I'm going to do this because some people say, I don't know what that is. So I have a calculator for you, and I'm going to do 25 minus 16, and that equals 9. See, just showing you that you can always do this in the calculator. So it's the square root of 9, right? So I'm going to put the square root of 9 over 5, and, well, that doesn't match anything. That's because the square root of 9 reduces down to 3. So what does that make our answer choice? D. So really all you need to know for this is how to identify A and C is related to A and B by this formula right here. C is equal to the square root of 25 minus 16 on there. All right, now this one's the challenge here. And yeah, you'll have one or two like this. Now, I don't know how well y'all can read it. I'll see if I can make it a little bit bigger. I might have to pull it back down some. Find the vertices, foci, and the equations of the asymptotes of the hyperbola. And you're given the hyperbola as x squared over 25 minus y squared over 36 is equal to 1. So this, is going to require a little bit of work in graphing, just a little bit here. So I'm going to put an xy plane over here. Okay? Now, just by looking at this, I know that my center is at the origin. Because this is up here, my equation, x squared and y squared is x minus 0, y minus 0. I know that. I'm also looking at the fact that my larger number is under the y, which is going to tell me something about the orientation. I also, if you will remember, we should identify, let's just go ahead and identify H, K, A, B, and C. H and K is 0, 0. Now, unfortunately, it doesn't tell us to find the center anywhere, so that's not going to be part of our answer, but it's going to help us to find it. A, B, and C. Remember, A is always the square root of the first denominator. So A is the square root of 25, or 5. That makes B the square root of 36, which is also 6. And C, if you'll remember, is the square root of 25 plus 36. Again, pull the calculator out. 25 plus 36. Well, I should put my mark down, sorry. 25 plus 36. All right, then let's try this one more time. Let's clear all that. Let me leave that part. Okay. Erase that part. 25 plus 36. Technology, you gotta love it. Square root of 61. Could I have done that in my head? Probably so. I just want to show you can do it in the calculator. Don't turn that into a decimal. We're not going to worry about that. All right. Now, unfortunately, that right there hasn't ruled out any of our answer choices yet. Not yet. Because now we need to, if you remember, we have to do a box. We know we're going to go 5 and 6 units around this hyperbola. The question is it 5 units to the right or left, or 5 units up and down? That's dictated by where the x is. The 25 is under the x, so I need to go 5 units to the right, 5 units to the left. That's a 5, not a 6. And then I need to go 6 units above, 6 units below. And the reason I do that is because I'm going to make a box here. And now, because the x is first, my hyperbola opens this way. And now I can begin to determine my vertices have to be right here and right here. So the vertices are at plus or minus 5, 0. Plus or minus 5, 0. Well, lo and behold, that automatically rules out 3 of our 4 choices right there. That automatically rules it out. So if we're comfortable with what we're doing right here, C has to be the right answer. It has to be. Because my vertices are not at 0 plus or minus 5. That would make them vertical. And since our x comes first, we have a horizontal transverse axis. It's not at 25, 36. So C has to be the right answer there. And then, of course, we can go further. Our foci have to be on the same plane, or the same line. So therefore, they're at square root of 61 plus or minus 0. The asymptotes, if you'll remember, are these diagonals. Again, we're doing more work than we need to, but I just am doing this to illustrate a few examples. So my slope here is up 5 over 6. And it's going to be plus or minus. And if I have the origin as my center, then it's going to be y is equal to plus or minus 5, 6x. 6 over 5, thank you. That's only 4 mistakes so far today. I think I'm doing okay. All right, so again, we put a little bit more work than we needed to in here, but what made this nice is that we were able to identify the vertices right quick, and that ruled out our answer choices. Had we not been able to do that, we would have had to go further with that. I have a question. Yes. What a pause. The question that was asked was, could we have ruled out B and D because the asymptote equation was x equals? Probably so. I just didn't see that early on. You know, can you have problems like this on the test? Well, yeah, that's the study guide is designed to show you that. All right, here's another challenge. Find the center and radius of the circle with the given equation. Well, there's your equation. I would hope that everybody in this classroom and everyone who's taken pre-calculus and everyone who has ever taken pre-calculus since the dawn of man will be able to identify that the center is going to have to be 7, negative 7, and the radius has to be the square root of 16, which you could say is plus or minus 4, but we're talking about radius, so that's a positive link. Well, where do we have a 7, negative 7, and a 4? The only now, I know some of y'all are up here going, well, it looks like B and it looks like D. What y'all aren't seeing up here is that, well, I'm sorry, no, B would have to be, D would have to be the correct one. I was about to say it looks like there might have been a negative in front of the 4 on one of them, but that's not the case. All right, so it has to be D. The next one, find the standard form of the equation of the parabola. Now, just by the fact that the way this thing is oriented, I know that I have y minus k squared is equal to 4p x minus h. That's my standard form, and I know that because my axis of symmetry is horizontal. In other words, it opens to the right or to the left. This one opens to the right, so that makes my p positive. So all I need to do now is identify HK. I hope all of y'all can tell the HK is the origin, so I'm automatically down to this. I'll go ahead and write it out this time. I'm automatically down to y squared. Y squared is equal to 4px. Okay? Now, just by the fact that this is oriented horizontally, the axis of symmetry, we could have already ruled out A, and if we can rule out A, then we may could rule out D. I'm not sure yet. I'm going to leave that open for a second. So now for us to do this, all we got to do is identify what P is. Well, P is the focus, and the focus is a point, and I illustrated it like this when we first started doing this. P is a point that has to be somewhere inside the parabola along the axis of symmetry. So I'm just bouncing it back and forth. I don't know where P is exactly. I don't know. So I can't find P by just simply trying to find a point. So what I'm going to do then is invoke some algebra. If I happen to know an x and a y that correspond to each other, I can solve for p. I happen to know two places where that happens. I'm going to look up here in the positive part. I know that 5 is equal to 4p times 5. Right? Now, remember, I can solve this for p, but then I have to multiply it back by 4. I'm really only interested in finding out what 4p is. Well, if I take 5 and divide it by 5, let's see, let's square this, sorry. If I take 25 and divide that by 5, isn't 5 equal to 4p? Isn't it? Then that means then that my equation is just simply going to be y squared is equal to 5x. Which one is it? It's going to have to be C. Okay, the next problem. Find the standard form of the equation of the specified hyperbola. Now, you're very likely going to have one like this on the test tomorrow. You need to understand that your picture may not be perfect. The hyperbola, part of it is right here. The other part of it is right here. Now, you have to understand it extends infinitely like that. But, you know, the whole hyperbola is not specifically put inside the picture. But enough of it is so that we can get the standard form of the equation of the hyperbola. Right? So a few key things about the hyperbolas. First thing is that you should have x minus h, y minus k squareds. And you do have in those cases all over some number, and you do. And there should be minus signs between all those. And they should all equal 1. And they do. So I was just circling that those are all. We can't rule out any of these equations right here just simply by one of them not being a hyperbola. So we're stuck as far as that part is concerned. So the next thing we want to do is identify HK. Now hopefully you can tell just by the way this is oriented, even though you only see, and I'm going to erase, we'll go ahead and go back to, even though you only see a little bit of the hyperbola on the left, you should know that you have a horizontal transverse axis. You have a horizontal transverse axis, which tells us something there. More specifically, HK is going to be the center, and I'm going to put it right here for now. I don't know exactly where it is yet. HK should be the center of those 2 points. Okay, now that being the case then, now we can pinpoint things just a little bit. I can tell by looking at this graph that our hyperbola, and I'm going to erase my lines, our hyperbola has an axis that goes along through here. I need to change colors. This line. I want to change the color because the blue is my transverse axis. So my midpoint has to be somewhere between the point 1, -1. That's this point right here. That's one of the vertices. And the other one is 1, 2, 3, 4, 5, 6, 7, 8, 9, -1. -9, -1, sorry. Now this requires you to have it right in front of you and being able to see it, but trust me when I tell you that I have vertices at 1, -1 and -9, -1. And I need the midpoint between those for my center. So all I need to do is use my midpoint formula. It's 1 plus -9 over 2, comma, -1 plus -1 over 2. 1 plus -9 is -8. -8 over 2 is -4. -1 plus -1 is -2. -2 over 2 is -1. So I know my center is at 1, 2, 3, 4, -1. -4, -1 is my center, which means then that I know that my hyperbola must have x minus -4 squared and y minus -1 squared. So in other words, I should have x plus 4 squared and y plus 1 squared. Now, whether one is first or the other, we'll figure that out in a second. But what I'm going to look for in my answer choices is everywhere I don't have x plus 4 and y plus 1, I can't use those. So in other words, I can rule out b automatically, because that is an x minus 1, y minus 4. And I can rule out d automatically, because neither one of those are in the form of x plus 4, y plus 1. I can rule those out automatically. All right, y'all okay so far, class? Now then, the next thing I want to do is, all right, which is first, the x or the y? Well, that comes from the orientation. We have a horizontal transverse axis, don't we? Which means the x part of things should come first. Unfortunately, that by itself does not rule out one or the other between a and c. So the next thing I look for is, where do I have an x plus 4? The only place I have that is c. It's the only place I have it is c. Right? Now, as I look further at this, I guess I could have rolled out a earlier, because a is x plus 1, y plus 4. I probably could have. But the idea behind this is in multiple choice, you can, if you understand how to construct that equation, you can begin to rule some answers out and pretty quickly eliminate and choose the correct one. So C has to be the correct one for this problem. All right, here is the question. It says find the standard form of the equation of the parabola, and you're given some information. You have a focus at -1, 4 and a directrix at x equals -3. Right? Now remember, your parabola looks like this. X minus h squared is equal to 4p y minus k, or it's y minus k squared is equal to 4p x minus h. Right now we don't know which is which yet, so it really is pertinent that we make a quick plot of this stuff. Now we're told we have a focus at -1, 4. So if I go to -1 and then up to 4, I have a focus right here. So that green dot is my focus. It's not my vertex, it's my focus. But it also says I have a directrix at the line x equals -3. Now x equals -3 is a vertical line that intersects at -3 on the x-axis. So if my focus is the point at -1, 4, and my directrix is the vertical line, x equals -3, does it make sense that my parabola must open to the right? Now, I don't know exactly where, but I know it must open to the right somewhere, right? Which means then that I'm dealing with this form of an equation right there. So anything that's x minus h, I can rule out automatically. So I can rule out answer choice A and D just simply because they're not oriented correctly. So now I'm down to B and C as my choices. So I got to figure out, is it B or is it C? And so it'll help if I identify HK. Well, remember, HK is the midpoint between these two parts right here. I'm just going to sort of draw a line there. That's where HK is. So in other words, the vertex is somewhere centered between -3, 4 and -1, 4. Now on a graph you can eyeball that, but I'm going to invoke that midpoint formula just because I've been doing that all along. So -3 plus -1 over 2 and 4 plus 4 over 2 leaves me with -2. This is 8 over 2, 4. So I know that my x is -2 and my y is 4. Have a question? Where do I get which 2 from? Right here, that is the midpoint formula. The midpoint formula is always x1 plus x2 divided by 2. That's the formula. y1 plus y2 over 2. That's always the formula for the midpoint. Okay? So, that means then that I must have y minus 4 squared is equal to 4p x minus, I said h, but I should put x plus 2. So as long as I have y minus 4, I'm good, and that is answer choice C. Now, had answer choice B also had a y minus 4, and an x plus 2, then I would have had to have looked at, is there a difference in the 4p part of things? So, just sometimes you have to further look into it, but C has to be the answer choice in this case. Y minus 4x plus 2.